Hey guys, today we're going to take a look at the second half of lesson 5.1, Intro to Normal Distribution. So our properties of normal distribution, the mean, median, and mode are all equal, and they're all whatever value is in the middle of your normal curve. That comes from the fact that the normal curve is bell-shaped, which makes it symmetric. So when we talked in our last packet about symmetric, that mean, median, mode were all the same. And symmetric about the mean just means that it's symmetric through that middle point, and everything on both sides is approximately the same. The total area under the curve is equal to 1 or 100%. So we write our answers in either decimals or percent forms. Properties of a normal distribution. This last property, it's a lot of words, but we're just really focused on what these inflection points are. So between mu minus 1 sigma, right here, and mu plus 1 sigma, right there, in the center of the graph, it curves downwards. And then at those points, it curves upwards to the left of mu minus 1 sigma and to the right of mu plus 1 sigma. So that point where it goes from curving down to curving up, we call those inflection points. And the really important thing to get from that is that those inflection points are at plus 1 sigma and minus 1 sigma. Okay, and then mean and standard deviation. A normal distribution can have any mean and any positive standard deviation. And the mean gives the location of the line of symmetry, that's that middle of your curve. And the standard deviation describes the spread of the data. Just like with our other forms of graphs, whenever the standard deviation was larger, the graph was more spread out. And the smaller the standard deviation, the less spread out the data is. So if we look here at these examples, on graph A, we have our line of symmetry here at our mean, our standard deviation of 1.5, so it goes out to here at our inflection points. You can see that this is the same mean that is on graph B, but B has a smaller standard deviation, so that's what's creating that skinnier, taller curve. Okay. And then graph B and graph C have the same mean, the same standard deviation, so they have that same shape, but the mean is lower on graph C, so we can see it's just further down that number line. Okay, here's an example. Which curve has the greatest mean and which one has the greater standard deviation? Go ahead and pause and try and figure out your answer and then come back. Okay, hopefully you got a chance to try those examples. The curve with the greatest mean would be A. You can see from those blue dotted lines, those lines of symmetry are our means, and A has a mean of 15, while B has a mean of 12. Then which curve has the greater standard deviation? That would be B. You can tell that B is more spread out. Those inflection points are further away from the mean than they are on A. And then example 3, the scaled test scores from New York grade 8 mathematics test are normally distributed. The normal curve shown below represents this distribution. Estimate the mean and the standard deviation. So take a minute, look at those inflection points, look at that line of symmetry, and decide what our mean and standard deviation are, and then come back for your answer. Okay, hopefully you got a chance to try that. We should have a mean of 675 if you look at that point, that line of symmetry. Comes down right there at 675. And then to find our standard deviation, we want to look at those inflection points because they're both one standard deviation away from the mean. So if we have an inflection point at 640 and an inflection point at 710, that would give us a standard deviation of 35, because that's how far each of those numbers is away from a mean of 675. Okay, a standard normal distribution. So just like we standardized scores in our first packet, we're going to take those standardized scores, z-scores, and we're going to create a standard normal distribution. So a standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. And that comes from our z-scores, because a z-score is how many standard deviations a data point is from the mean. So each sigma, each standard deviation away, is 1 z-score. So any x value can be transformed into a z-score by using the formula for a z-score. So our formula is value minus mean over standard deviation. So that's x minus x bar over sx, or x minus mu over sigma. If each data value of a normally distributed random variable is x is transformed to a z-score, then the results will be the standard normal distribution. So in our normal distribution, we could have numbers, we could have a mean of 50 and a standard deviation of 7. But when we take all of those data values and we convert them through our z-score, that's how we get our mean of 0 and our standard deviation of 1. So use the standard normal table to find the cumulative area under the standard normal curve, and that table is on page 7 and page 8. So we're going to use that on example 4 and example 5. So the areas that are found on the standard normal table are all talking about the areas to the left. That's what the cumulative area is the area to the left. So here, example 4, wants our area to the left of z-score of 1.15. So let's draw that out here. We'd have our mean in the middle, and then a positive z-score is going to be to the right. A z-score of 1.5 would be about here. We want everything to the left, so we're trying to fill in this area right there. Okay, so if we go in and we find a z-score of 1.15 on our table, it should give us a value of 0.87493. And if we write that as a percentage, 87.49%. Okay, example 5 wants the same thing, wants the area to the left. This time a z-score of negative 0.24. So our mean would be down the middle. And then negative would be to the left, negative 0.24 around here. Okay, we want everything to the left. And if we go to our standard normal table, that's going to give us an area of about 0.40517, or 40.52%. So the standard normal table only tells us the areas to the left, but our questions aren't only going to ask us to the left, so we need to talk about what to do when it's not just talking about to the left. But A is to find the area to the left. All you do is just use that corresponding number that we find in our table, because all those tables are to the left scores. To find the area to the right of a z-score, you take the standard normal table answer and you subtract that area from 1. So 1 minus table value gives you your answer, because 1 is the whole area, and then if you subtract that to the left area, that's what leaves you with our answer. And then to do between two z-scores, you find the area for each corresponding z-score in the standard normal table, and then subtract the smaller area from the larger area. We want to make sure we subtract the smaller from the larger because areas have to be positive. So you take this big z-score, this big area here, and you subtract this smaller one, and that leaves you with our answer. So go ahead and try examples 6, 7, and 8. Try those 3 problems, pause, and come back for your answers. Okay, hopefully you got to try those 3 examples. Example 6, we're talking about to the left of negative 0.99. So we just go in, find that table value. So you should have gotten 0.16109 or 16.11%. Example 7 wants us to find the area to the right, so we have to do 1 minus our table value. So we find our table value for 1.06. 1 minus that should give us 0.14457 or 14.46%. And then example 8, find the area between those 2 scores. We do the bigger minus the smaller. So we find our 2 table values and subtract them. We should get 0.82754 or 82.75%.